Hi, we have the AP Physics 1 past paper 2018. We are discussing the section free response question. We have question number 2 which carry the 12 points. In this question, a group of students prepare a large batch of conductive dough, a substance which can conduct electricity, and mold the dough into several cylinders with the various cross-sectional areas and the length. Each student apply a potential difference delta V across the end of the dough to determine the resistance of the cylinder. The results experiment shown in the table. There is a various cross-sectional areas, different length. This the potential difference applied across the dough, and here's the calculated resistance value. Okay. The student want to determine the resistivity of the dough cylinder. Okay, in part 1, indicate below which quantity could be graphed. To determine the value of resistivity of the dough cylinder, you may use remaining column in a table above as needed. Record the quantity including unit, not they are not already in a table. Okay. So we have to make the graph. Therefore, we have to define the axis, horizontal axis and vertical axis. As we know that resistance formula R is equal to rho L over A. Rho is the resistivity. So we just modify the formula in this shape. Resistivity is equal to rho over L over A. So resistivity can be found by using the slope of the graph delta Y by delta X. From this tool, you can see resistance is along y-axis and the L over A is along delta X horizontal axis. That's slope indicating the resistivity. Okay, so we can conclude vertical axis should be resistance and the horizontal axis length per unit area. So in previous we have the resistance to draw the graph, and next we have required L over A. From these two quantities we make the third column, new column L over A with the unit per meter. So the ratio of both these is equal to indicated in a table. Next, on the grid below the plot, appropriate quantities determine the resistivity of the dough. Clearly scale and the label all axes including unit with appropriate. So as we know that resistance is vertical with the unit of ohm, L over A with the unit of per meter. All those points are designed with the scale. A horizontal axis have the 50 interval for big scale and the 20 along the vertical scale. We have placed all the value according to the table. This is the line. One of the point is not on the line, might be not correct experimental value. Okay. Then in next question, use above graph to estimate the value of resistivity. So graph can be found through the slope as we conclude in the question 1. So we take any 2 points between on the graph to calculate the slope or resistivity. As you've seen, I have taken the first and the last one. So answer is 0.403 ohm. There is a final minus initial value. That's the final value 105, initial value 23.6. You can see from these two values we have taken the graph, these two and these two. Okay, so answer is B 0.43. If you take different pair for to calculate the slope, their answer may be not as same. It might be 0.39, 0.42. So estimated or average, you can say that it is 0.403. Another group of the students performed the experiment described in A, but the shape of the dough long rectangular shape instead of cylinder. Will this change affect the value of resistivity determined by the second? Yes or no, with the answer with the 1 point reasoning is no. Because resistivity is the intrinsic property of the material, it doesn't depend upon the shape. So independent of the shape, of whether cylinder or long rectangular shape, resistivity would be same. Okay, in next part, describe the experimental procedure to determine whether or not the resistivity of the dough cylinder depend upon the temperature of the dough. Given enough details so that another student could replicate the experiment as needed, included a diagram of the experimental setup. Assume experiment equipment is usually found in a school, physics laboratory is available. First of all, we describe the experimental setup. First, mold the piece of conductive dough into the cylinder shape. Measure the record length and the cross-sectional area. These value would be remains constant throughout the experiment. So we have L, we have A. Now insert the two clean metal strips or the nail at the end of the dough to the that would be act as a current contacts without damaging the shape. Connect the dough sample in a simple circuit with the power supply. The ammeter, ammeter is series in a circuit, and the voltmeter that is parallel to the end of the dough across the dough. Now insert the digital temperature sensor in the center of the dough or the digital thermometer to measure the internal temperature accurately. Now to vary the temperature, place the dough sample into the temperature bar to check the resistivity at different temperature. This is the experimental setup we have designed to check either resistivity depend upon the temperature or the not. Experimental procedure, let's start at the room temperature, say T1. Turn on the power supply. Now there is a current in a circuit. We calculate the potential difference across the dough from the voltmeter and the current through the ammeter. From voltmeter and the current, we can calculate the resistance of the dough. Now increase the temperature to water bath using the heater. Wait the temperature to stabilize to the new higher value. Record new temperature T2. Now at this temperature, again repeat, switch on the battery power supply, calculate to potential difference and the current through the circuit, and then we can calculate the new resistance. We have to repeat this process at least 5 data points, 25 Celsius, 35, 45, 55 or 65 at the several range of the temperature. At each temperature, we would calculate the resistance. So from each resistance measure, we can calculate the resistivity. From experiment, we calculate R, and A or L is the constant as we described in the initial statement. Okay. Now we have to plot the graph between the resistivity and the temperature so we can check their relationship. Resistivity should be on vertical axis, temperature should be on horizontal axis. If the plot shows the rho changes as the T changes, then the resistivity or dough depend upon the temperature. If the resistivity remain constant, it doesn't depend upon the temperature over the range. Mean if the temperature is changes but the resistivity answer is always remains same. So its mean resistivity is independent of the temperature. But if the temperature changes and resistance changes, resistivity changes, so its mean the resistivity of the dough depend upon the temperature. Okay, that's the answer. If you find it helpful, kindly subscribe and share with your friend. If you have any query, kindly ask in a comment. Okay, take care.